Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using KNIME. In this chapter we're going to cover multiple variable regression, which instead of using a single variable, we're now going to use multiple variables. Simple linear regression, the focus of our last few chapters, focused on predicting a single dependent variable from a single independent variable. Multiple regression is an extension of simple linear regression. It's used when we want to predict the value of a variable based on the value of two or more variables. So in this case, there's going to be multiple independent variables and a single dependent variable. So let's take a look at how we do this in KNIME. And I have altered the sample movie database. And let's take a look. So I've now got three columns. I've got the book sales, and I've got an amount of money spent on promotional spend, and then the production movie costs. And those three variables we're going to use to predict movie revenue. Okay. Now, my regression learner, instead of having one column, now I've got three columns that are feeding the regression learner, and I'm still generating the prediction for movie revenue based on those three values. So when I output and look at this, first let's take a look at our results view. The R-squared value is 96%, so I've covered a substantial amount of information. There's still 4% of the movie revenue that's variable, but 96% of it is guesstimation. But I've still got now my y-intercept value right here at 7.783. And then each of these is the coefficient of these variables. So what we're going to do to compute our formula is multiply 0.85805 times book sales, 7.6034 times promotional spend, plus 3.6929 times production costs, plus the y-intercept 7.3813, and that will give us our predictive value. I'll show this on another slide so you can see the actual formula generated from that. And finally, let's look at the scatter plot view to see our regression line, and you can start to see it varies a little bit, and as the dollars go up, so as we spend more and more, it's less effective at doing the prediction. But overall, the R-squared is fine. And I'm going to look at the scatter plot diagram for my residuals like I've done in the past. And I'll look along the zero-axis line right here, and I can see that there's randomly dispersed above and below the zero line. I don't see any patterns that indicate a curvilinear relationship, so this is looking good right here. So one more time, looking at the regression line and the values for the coefficients, and the y-intercept at 7.3813, we can now determine that our formula for predicting Y production movie revenue is going to be 7.3813 times plus 0.805 times book sales plus 7.603 times promotional spend plus 3.693 times production costs. Those three each value together added with the y-intercept gives us our prediction for movie revenue. That completes this chapter of the class. Feel free to move on to the next chapter.